So, hello everybody. My name is Jong Kim and I'm from Korea and I'm a student in Korean Advanced Institute of Science and Technology, known as KAIST. And today, I'm gonna share you briefly about my previous research that I did in which I was in my high school period. And also, I would like to share some words for you too. So in 2022, I ran in the regional ICF, which was held in Georgia, United States, and I was able to get a third main prize and also a special prize from the CAO. So my research is briefly about the antibiotic resistance of a specific bacteria that causes tuberculosis. So, would you believe that a quarter of the world's whole population is infected to a highly lethal disease that kills millions of people every year, and that there's currently still no way to cure this disease in its dormant state? Tuberculosis is a highly infectious respiratory disease caused by Mycobacterium tuberculosis, which a quarter of the world's population is currently infected somehow. And it is known that it was the second leading cause of death in 2020, back in 2020, only after COVID-19. So, however, MTB, it is especially strong resistant to antibiotics during the dormant and its inactive state. So it requires way more time and efforts to be cured. So me and my friends back in 2022 have aimed to discover how MTB, which causes tuberculosis, interferes the effects of the antibiotic drug. So we have especially focused on a drug called rifampicin. So it is currently used to treat tuberculosis, but it is not very effective to the dormant state tuberculosis. So we have chosen Mycobacterium smegmatis as our model organism for research, which is a non-pathogenic version strain of Mycobacterium genus. So we have adapted use of this called the sigma factor. So as you all know, transcription begins when sigma factor binds to the core RNA polymerase to form a holoenzyme. But this process is very important because if transcription fails, the bacterium will not survive. And during this process, sigma factor is very, very important. And also, it is found that sigma factor is important for MTB to survive in harsh environments. So these are just some prior researches that have been done before our research. So the prior researchers have found out that some of the sigma factors, they were inactivated when transcription factors were being active. So as you can see in this zone inhibition assay results, you can see that when we deactivate specific sigma factors, their ability to resistant to the antibiotics, they change. So was our key hypothesis. So rifampicin resistance increases in delta A3 mutant. It is found in previous research, but we thought that it is due to genes related with sigma factors SIG-B and SIG-E. So we have to find genes that showed statistically significant changes in their gene expression levels when sigma factors B and E were inactivated. Also, we have to verify correlations of sigma factor B and E regulons and rifampicin resistance. So we have used this plot. So we have plotted all of the genes. We have analyzed everything. And then we have found some genes which were upregulated or downregulated. And we have removed the sigma factors E and B. And we have found some interesting correlations. So the first of all, sigma factors B and E regulars, they overlap each other, and also these regulants show increased expression when A3 cytochrome C oxidase is inactivated, which I have previously mentioned. So we have ran a beta-galactosidase assay to see the actual change of the activity of genes. So through this experiment, we have actually explained the correlation that we have found that sigma factor E transcribes the genes required to assemble sigma factor B. So we have run also the QRT-PCR to numerically prove our point of the research. So we can see here that some genes are repressed and other genes are induced when specific sigma factor B genes are altered in their measurements of activity. So we can see here, through our experiments and assays, we were able to select two of the genes as the candidate for the antibiotic resistance of MTB. So as you can see here, when we altered the activity of specific genes here, the antibiotic resistance has actually went down regulated, which means that these genes would be highly suspected to show some antibiotic resistance when related to other sigma factors here. So this is the point of our research. So we had actually proposed that first of all, sigma factor B gene is transcribed by sigma factor E. So, and also from the zone inhibition assay, which I have explained just before, that the increased expression of these genes contributes to increased antibiotic resistance. So these were the key points of our research. And also, I would like to share a brief piece of advice to the students dreaming of becoming a scientist. So, as you can see, we often think scientific research as a purely logical process, but however, I believe that breakthroughs comes from a balance between analytical skills and a creative and challenging spirit. So, as you conduct experiments in the future and prepare to present your findings, I hope that you should try not to get lost solely in the numbers. So while data is very important and is the foundation, it always does not explain the whole story. So instead of focusing only on what the results are, I encourage you to take a moment to reflect on the why side. So why did these numbers appear, or why did this sample become this way? So taking the time to contemplate the deeper significance of your research will not only make your presentations more compelling, but will also fuel your passion for discovery. So keep questioning, keep creating, and remember that your perspective is just as important as your data. So thank you for listening to my story, and I hope this was a great opportunity for everyone. Thank you.